It is given that k is a positive constant. By sketching the graphs y equals 14 minus x squared and y equals k log x on a single diagram, show that the equation here has exactly one real root. The real root of this equation is denoted by alpha. Find by calculation the pair of consecutive integers between which alpha lies. Use the iterative formula here with a suitable starting value to find alpha. Show the result of each iteration and give alpha correct 2 decimal places. So there's the question then. I've got the summary of it here. So let's have a look. So we need to do a sketch of this. Basically, okay, so I'm going to separate this out now. I'm just going to take this second section and move it out of the way for the moment, and we'll come back to that later. Let's just do the first part of the problem then. So we need to do a sketch of this. So let's just draw an axis. Okay, and we need to sketch this. Okay, let's just move that up then to here. So we're going to sketch, oops, I've moved the of now, which is great. Okay, so let's have a look at this then. So 14 and y equals k log x for k's positive value. Well, 14 minus x squared. It's a quadratic, so it's a u or an n-shaped curve. The x is negative, so it's an n-shaped curve. And here we can see this has got roots either side of the x-axis of root 14 plus and minus. And root 14, we can just see that by inspection, can't we? So here's our curve. I'm going to use a dashed line because it's a digital pen and it's difficult to draw accurately. When x is 0, it goes up to 14. So it's quite steep, and then it comes around like so. I'm going to do this little section again, I think, here. And it comes around and down here, the same as the other side, symmetric. Okay, so that's the y equals 14 minus x squared, and the highest point here is 14. And then we do y equals k log x. Well, when x is 1, log of 1 is 0. So this is the value k. For some positive k, it's going to come up here. So it could come up anywhere really. But supposing that it comes up here, so I'm going to sketch a log function here. When x is 1, x is 1, so we get that there. And then the curve flattens out like so. That's the log function. So as I say, when x is 1, we get log 1 is 0. So this point here is 1. So really I should have drawn it back a bit more, shouldn't I? So maybe I'll do that then. I'm going to mark off 1, which I'll put about here. And then the curve's going to shoot up here like a logarithm, steeply, and then it's going to turn like so. And this is y equals k log x. And the root is here, of course, when they equal one another. Okay, so that's the place where the equations are equal. Okay, good. So that's the sketch then. Now we move on to the next part of the problem. The real root of this, when k is 3 here, is alpha. So let's have a look at this then. This was 1. So it would presumably, this is root 14, so it would be 4 would be up here, 3, so it would be sensible to look between 2 and 3, wouldn't it, to see if there's a root. So the real root of this is alpha. Find by calculation the consecutive integers between which alpha lies. Okay, so here let's do part 2. So here let's put in the value 2. 14 minus 2 squared is equal to, so I'm going to do the difference. So I'm going to do that. Take away 3 ln 2, and then we're going to do 14 minus 3 squared minus 3 ln 3, and we'll see if a change of sign occurs here. So 14 minus 2 squared is 14 minus 4 is 10, minus 3 times ln 2, and it's 7.92. Now if we do 3, we'll have 14 minus 3 squared is 14 minus 9, which is 5. Take away 3 times ln 3, close bracket, equals, and that's 1.7. Let's just get that number again, 1.704. So let's do the fourth value then, number 4. 14 minus 4 squared minus 3 ln 4 is equal to 14 minus 16 is minus 2, so negative 2 minus 3 times ln of 4. Get rid of the answer from before. It's 14 minus 16 is minus 2, so equals minus 6.15. So a change of sign occurs between, a change of sign, a sign occurs between x equals 3 and x equals 4. So if we go back to the sketch, so the 3 must have been here, so this must be just past 3, and 4 would be up here, but still 3 could be here, and that's just after it, isn't it, so to speak. So we've done that then. So let's find alpha to 2dp. So we'll take x x0 or x1. Let's just look back at the question, see how it's written to be absolutely sure. With a starting value, so let's try x1 and work from there. So x1 is equal to 3, and then we want to find out the other values, don't we, according to this formula here. So x2 is equal to the square root of 14 minus 3 ln x1. Okay, so let's put it in our calculator then. So we'll move our calculator over here. And now x1 is 3. So we've got that in the answer now. So we want square root of 14 minus 3 times ln of the answer, which was 3, close bracket, equals 3.271. So x2 is equal to 3.271. x3, so let's press equals again, 3.231. x3 is equal to 3.231. x4 is equal to 3.237. 3.237, and x5 is equal to, let's just press it once more, 3.236, 3.236, and so on. So use this to find alpha to 2dp. So it seems as though we're settling around 3.23, doesn't it? Or 24 rather. So we're going to try x is equal to 3.24 to 2dp. So let's work that out then. So here if we've got 14, the square root of 14 minus 3 ln no, the change of sign rather. The change of sign, I need to do that. Where is it now? 14 minus x squared is equal to 3 log x. So 14 minus x squared minus 3 log x. So let's have a look at that then. So it's 14 minus x squared minus 3 ln x. Okay, so if we have f of x is equal to, then we want to look at f of 3.235 is equal to, and we also want to look at f of 3.245 equals, and see if the root lies between these two values then. So we've got 14 minus x squared, which is 3.235 squared, minus 3 times ln of x, which is 3.235, close bracket, equals 0.012, 0.012. So that was that one. Now we go along the equation here, and we change the 3 to a 4, don't we, to try the next value. 3.245 minus 3.245 equals, we get minus 0.06. That's a 0.06. I'll put the comment up here. So a change of sign occurs, and the root lies between. So alpha is equal to 3.2 in between here to 2 dp. Both of it will be 3.24, and that's to 2 decimal places.